In this video, we're doing how to know when to do what type of integration for Calc BC topics only. So let's start with integration by parts. There's a type of integration by parts which we call round and round, and that's a BC topic generally speaking. We have two functions multiplied together, and if it's a combination of e to the x and either sine or cosine, it's a round and round. We'll be using uv minus the integral of v du on these. It's important to write the original problem each time and keep integrating until your final integral on the right side matches up with the original problem on the left side. Again, here we would have a round and round, but be careful about e to the 3x because there is an inside function there. Partial fractions is a BC topic. Remember, with partial fractions, you're looking to factor the bottom. So maybe this is x minus 5 and x plus 1. So a over x minus 5 plus b over x plus 1 equal to the original. Then make like fractions. If there's nothing up top there, set it equal to 1. In our second one, we have an x plus 1. So again, if we factor x minus 5, x plus 4, we've got our a over x minus 5, our b over x plus 4. And again, setting that equal to x plus 1 after we make our like fractions. In our third example, and this should be a square, if we factor out an x squared and we get an x minus 9, we have a repeated root. So remember, with a repeated root, we have to break that down as a over x plus b over x squared plus c over x minus 9 equal to our original problem. Make a common denominator, set it equal to the top, in this case 3, and then finish the problem. Trig substitutions. So you've got a u sub, which is going to create a cosine squared u at some point. Realize you need to be able to substitute 1/2 1 plus cosine 2u in place of here to get rid of that square, because we don't have a sign here to help us with just a normal u sub. Again, on this side, our key substitution is for sine squared u, which is 1/2 1 minus cosine 2u. So again, remember, to get rid of the square, you need to use this trig substitution. Improper integrals, perhaps the one we need to pay attention to the most. We have individual videos on all of these topics, but in particular improper integrals. You recognize improper integrals when you have an infinity in the lower bound, in the upper bound, or in both bounds. Remember, you need to replace the infinities with an L temporarily and take the limit. It's important to use proper notation when you take the limit. Make sure that you show your limits. If there are two infinities, then you're going to have to split the problem up into two pieces. Down here on the bottom, these are the ones that AP is going to trap you with. If you're not paying attention, you're not going to notice that this function is undefined at 2, so your L is going to go there. In this problem, again, your top bound is undefined. In this third example, notice that 1 is undefined and 1 is between -2 and 4, so we would have to split this one apart. If you need more help on improper integrals, see the individual videos for improper integrals.